So the first lesson today is about radians. You definitely need something to write on. So you can do the examples and you can write down the concept. Because even though you might have done SOHCAHTOA in the past, sine, cosine, and tangent, we are learning more and different trig than that. So this is probably something you have never touched on. I think there was only one person last period who said they might have seen part of it before. We're going to start with a discussion about angles. So the first thing is that the positive x-axis, if you imagine a coordinate plane with this dot, the center of the circle being the origin, the positive x-axis, which is this way, is 0. That would be 0 degrees and 0 radians. We're going to be learning about radians today. That is 0, that is our starting space. If you go counterclockwise, you are doing a positive angle. If you go clockwise, you are doing a negative angle. You should remember from geometry that angles and intercepted arcs have the same name. So if I made an angle here and I said it was 30 degrees, that's also a 30-degree arc. Right? The measure at the middle is the same as the arc on the outside. And lastly, we have this thing here. It is the Greek letter theta. It's what we use to name the angle. Now my thetas, depending on how fast I'm writing, can look like this, or look like this, or look like this. More often they look like that. I'm just letting you know those are my thetas. So when you ask me what that thing is that I wrote, it's a theta.
What's it called when it...
So, discussions that have come up. Make sure we all understand what's going on here. If I said an angle of 270 degrees, that'd be positive because I said 270, so that could be 270 degrees. I could also call that negative 90 degrees, right? So you could name something two ways depending on which way you're going, whether it's the positive or whether it's the negative.
On a test, if you said to draw the 270 angle, but we made it negative 90, would that still be correct? Or would
So,
we make it 270?
a lot of times when we're working with things, how you're going to know whether it's the positive or negative is the correct answer is the domain that you're given. So if they tell us that we're going to work from negatives to positives, we can include negatives. If they tell us to only use positives, we're only going to use the positive. So it depends on the information you're given as to what you want to work with. Okay? Now, let's discuss circumference and arc length on a unit circle. So unit circle is very important in trig. And we're going to start with what is a unit circle. Is a unit circle. Something is called a unit for a reason. That unit is the radius. And how big is a unit? 1. So a unit circle specifically has a radius of 1. By calling it a unit circle, you know its radius is 1. So what is the circumference of this circle? Circumference of the unit circle would be 2 pi. Radius is 1, so my circumference is 2 pi. In trig, it is fine to leave pi in your answers. There will be times when you want to use decimals, but now I don't. I want to use pi. So my circumference is 2 pi. Remember that means from my starting point all the way around and back, my length that I've gone is 2 pi. So circumference is the same in a unit circle as its arc length. That distance I just went around is 2 pi. Does that make sense?
So the arc length is just the circumference.
Of a unit circle, yes, they are the same.
Is it only a unit circle?
Correct. Later today, we will find the formula for arc length of any circle. Right now, just the distance around, that is the circumference of this circle. So circumference in this case equals arc length. Everybody's okay for right now? Now, let's say I wanted to do an angle that was straight across here. How far did I go?
180, 180, 180.
So, if you're telling me degrees, you're telling me 180.
You went pi.
If you're telling me how far around the arc I went, if all the way around the circle was 2 pi, this much around the circle is pi. And remember how we said the arc and the angle are the same? Radians are the measure of the arc that we can also call the angle. And I will show this again in the next slide.
So then, would that mean pi would equal 180?
Pi equals 180. Pi radians is the same thing as 180 degrees. They're different measurements of the same thing. So if you want to think about it, like 1 foot is the same thing as 12 inches, right? 2 different measurements, same amount of distance. Pi and 180, 2 different measurements, same amount of distance.
Is that only for unit circles?
No. We're going to talk about the radians, the actual radians themselves, that sort of degree idea will transfer to other circles.
So pi equals 180 all circles.
Mm-hmm. Pi equals 180 in all circles.
What if you did had a radius of 2?
Then we'll talk about arc length separate from the angle.
Okay.
When you get outside of a unit circle, you talk about arc length separate from its angle.
Alright.
Okay, now what if I went only this far? So it's half of pi, which in trig we say it's pi over 2. It's half of pi, we say it is pi over 2. What about if I wanted to go 3/4 of the circle? So I'm going down here. How do you think I'm going to name it? How many pi's did I go? It's 3 pi over 2. Remember, all the way around is 2 pi. Halfway around is pi. So I've gone pi and another half of a pi. That's 3 pi over 2. That's 1.5 pi's.
It's 2 pi, so 3/4 pi would be like a 45 degrees. Okay.
And if I wanted to finish going around, I always start here, which we said was 0, right? But if I go all the way around the circle, I end up back here, and it is known as 2 pi. So that particular angle, depending on whether you're saying you're starting there at 0 or you've been all the way around, you call it 2 pi. It is known as both. We will be using and exploring more about the unit circle in the upcoming lessons. Today we're going to focus on this idea here in just a minute of pi equaling 180 and using that as a conversion factor. So once again, this just is another way to look at that relationship between degrees and radians. Degrees were specifically developed using and this is stolen from another teacher, the tip of the pizza. So the degrees were specifically started using that small angle measure. Radians actually deals with the amount of arc that you've gone past, which deals with the radius of your circle, hence radians. But just like you can name the central angle the same as the arc, they are interchangeable. So we want to convert from degrees to radians. So remember how we had that idea that pi was the same thing as 180? Just like you know that 1 foot is the same thing as 12 inches, and if you want to convert, you make it into a fraction and multiply. That's what we're doing. So if we're starting off with 45 degrees, we want to convert that to radians. We're going to multiply that by pi over 180. That's our conversion. Pi over 180. Right now I want you to give me a fraction and leave the pi in there. Don't give me a decimal. So I'm going to reduce this. If it helps, you can put 45 over 1. 45 goes into 180 4 times. I get pi over 4. It's pi over 4 radians. Try these two right now. Compare your answer with your partners. Convert these from degrees to radians. Okay, so for the first one,
What are you doing?
you should have ended up with pi over 10. Everybody's good with pi over 10? What do you end up with?
Negative 28.
You just get negative.
So, it doesn't go in evenly. Let's talk about reducing fractions. What goes into both 225 and 180?
15.
Okay, 5 is probably the first one that most people see. So let's try this. Reducing by 5 is going to give me 45 there and 36. And then is there some number that goes into both 45 and 36? 9, and that's going to leave me with 5 and 4, so I've got negative 5 pi over 4 as my answer.
Oh, yeah. So if I did it by 15, I just...
Let's go the other way. Given a radian, go to degrees. So now we've got to take that conversion factor and flip it around, so now we've got 180 over pi. So we're given 2/3 pi, which if you want, you could write that as 2 pi over 3 radians. Our conversion factor is 180 over pi. What do you notice? Pi's cancel. I could then say 3 into 180 is 60 times 2. I've got 210 degrees. Ask me questions. Okay, so there we have 120. Good? What if you were given the problem, like your homework, that's going to say 7 radians?
That basically just means 7 pi. Okay, that's not right.
It doesn't mean 7.
So it just says 7 radians. This is the radian measure, 7. So you're just going to do 7 times 180 over pi. This isn't going to be pretty. 7 times 180 is what? Somebody help me out.
A big number. That's what I was going to say, Maddie.
1260.
1260. So I would accept 1260 over pi, or you could give me the decimal, which is...
Well, there's not a decimal given.
No decimals.
There is a decimal.
401.07.
401.07?
Decimals.
Okay. So I'm telling you that unless it specifies in the directions that you have to give me a decimal, I will accept 1260 over pi, or I will accept the decimal when they're not pretty. When they turn out pretty, I want them pretty. Okay? So if it's something you can reduce,
No, I need.
oh, sorry.
I need to get it. Why is it like? Why is it 100
I did 2 times 60 after I reduced my 3 and 180.
What if they give you a number that's like more than, oh wait, that is a number that's more than 360. Is that even like possible?
Yeah, it just
Like, I
means
know-
you go around the circle more than once.
Okay. Didn't know if we were limited to like 360.
No. No, if you get something that's over 360, it just means when you started, you went around and you kept going to wherever it was that you stopped. Yeah. So that your angle would be here. So just like we said, 0 and 2 pi are the same thing. That happens as many times as you want to go around a circle.
What the heck is that?
Okay. With your partners, try these radians 2 degrees. Okay, did you get 90 degrees for the first one?
Yes.
Did you get 210 degrees for the second one?
Do number one.
Good.
Number one.
For that one.
Yeah, I am stupid.
2. I know.
She's literally not looking and she's doing it.
But like I need 2.
Okay, so hold on. Let me finish one and then I'll do
That's
2.
what I confused about.
2 is 90.
Oh, I get 1. Oh, you're talking to someone behind me. Oh, I
Yeah,
get
sorry.
Oh,
No, I.
Oops.
Okay, so you need number 2?
I got it.
Quinn, you need number 2.
Yeah.
Okay.
It says cross
Everyone makes mistakes.
So the pies are going to cancel.
Never come.
I like to reduce. 6 goes into 180 30 times, and 7 times 30 is 210.
I don't know how I did this. I like said that like it was 7 pi over 6.
Uh-huh.
And then when you got the pi at the bottom, you got 7 pi times 180 over 6 pi, so those would cancel out. So I got 180 pi. Because I thought there were like 7 pi's over
Okay,
6
that
pi.
goes back to the discussion we had on the other side. When you're multiplying things. So think of, for a moment, side problem. Think of 2 times 5 over 5. What's the answer?
2.
2. Yeah, I know, that's where I got confused.
Okay, but it's not, when you did 7 pi divided by 6 pi, you were thinking you had a pi left. That's what you do when you've got an exponent. A pi times a pi times a pi times a pi. Not when you're multiplying 2 times a pi. Or 2 times a number. Okay, last thing for today is arc length. This is a formula you need to know and memorize. Arc length. Arc length is S. Don't ask me why, it just is. S equals R theta. R is your radius, theta is your radians. So your angle has to be in radians. And this goes back to the discussion we were having earlier when we said radians and arc length were the same on the unit circle, because the radius was 1. But when you change your radius, this is the equation you need. You need radians times your radius. Radians is just that angle measure.
I'm sorry.
Oh, so like. Stop.
Pi over 10.
So it depends on the problem. We've got a problem here. And we are going to find the arc length of S. So what it's asking us for is this arc length right here. Right? That arc length right there. So S equals R theta. What is the radius of this circle?
3 inches.
3 inches. You see right there, it tells me that 3 inches is my radius. And then what is the angle measure of that arc in radians? 5 pi over 6. So then you do 3 times 5 pi over 6. And you get 5 pi over 2 or 7.9 if you have to do the decimal. And that is the arc length of S for that circle that we had as. The next problem is going to be what is the arc length of B. So if you understand, do the arc length of B. So using that information to do the arc length B, which is this arc length right here, the radius is 3. My radians is 2 pi over 3. So this arc length right here is 2 pi. Good?
Oh, I did it. Wait.
Oh, wait.
Um,
Huh? It's an S. It's not a 5.
sorry.
It's okay.
Wait.
We just did that. All right. So, your homework for this unit will be on worksheets. I'm going to give you this worksheet, and then in a moment, we are going to all flip it over, and you're going to make sure you can read the numbers on the back. This worksheet is at least 4 years old and has been through many different copies and scans, so it's a little bit hard to read. I apologize, we didn't have time to retype it. So if you turn to the back of your worksheet, these are the numbers you need, the thetas and the r's. Also, if you happen to miss something, the copy that is posted online has them written to the side as well. So they are a little bit clearer online if you need to reference that later.
Wait, so
So
the radius
we're
is the
finding
letter?
the arrow.
Yes, you're finding the arrow.